we need to talk about security, and in this case, DevSecOps. We all know DevOps. With DevOps, we tried to tear down the wall between the developer organization and the operations folks, glue them together to be better, faster, and stronger. Basically, what we try to do is create and maintain what you own. Basically, take ownership of what you create. And nowadays, it's not only your application anymore. It used to be the application, threw it over the wall, and the ops teams took care of deploying it and maintaining it in production. Nowadays, that's not the case anymore, especially not with cloud-native applications, where we now have our environment and our infrastructure as part of the code base. We need to also take care of security in that matter. I mean, if we take care of things like maintainability and scalability as part of the implicit things we do as we code, security should be one of them as well. And I will tell you why in this talk. So, my name is Brian Vermeer. I am a developer advocate for Sneak, Java champion, and I do a ton of stuff in the community, like leading the virtual jug and one of the co-leads of the NL jug in the Netherlands. I'm based in the Netherlands, and for Foojay, I am the community manager for security. However, let's talk about the real things in life, like what are the problems that we're trying to solve with that DevSecOps kind of thing. Well, first of all, we try to deliver software at a lightning pace. I used to work in a government agency, and back in that days was like 15 years ago, we maintained software and we only released like 3 times a year. Nowadays, you see that companies release multiple times a year. However, we are focusing on features. And is that good? Because if we only focus on features, implicitly we take some shortcuts, like security. It's not so much on the mindset of either the developer or the old-fashioned operations folks. But we do need to take care of that, because the point is this time is that the security expertise within teams or within organizations is still siloed at the end. Multiple engineering teams led by basically one security team that tries to help everybody or declines every request and stops you from going to production. That can create friction, especially if we developers don't take security seriously from the beginning when we are developing our applications, our containers, and our infrastructure. Nevertheless, we need to take care of that because we don't want our customer data to be compromised or our application integrity to be compromised, right? Okay, let's go from that. Is that situation so bad? Well, let's get to that. I mean, first of all, if we think about applications and application security or maintaining applications, we might think of our own code. Our own code is the thing, our bread and butter, the thing that we do, the thing that we create, and the thing that we maintain. We might have things like QA in place, we have pair programming, or even things like code reviews. However, this is just the tip of the iceberg. This code is essentially very important, is the business logic. However, it is only 10 to 20% of the code base or of the actual application. If we look into this piece of code, I created a Spring Boot application, and with this piece of code, I created an endpoint, basically my endpoint / hello. But as you might be able to see, there's already a security issue in this. Let's take a look at that. As a parameter, I will give the string user or the username or whatever that is. However, this parameter that is part of the request, I directly write it back to the response writer. The problem is I don't do any sort of sanitization, which comes back into a cross-site scripting issue, and that is not what we want. Think about it. If I do say things like /hello and I gave the user script alert1 /script, we will have an alert. But it's not only that. Cross-site scripting can be there in many, many cases, like mouse overs, image tags, or all sorts of other things. Well, this one was easy, but let's get into an example where it might not be that easy to find. This is the Spring Boot application I was telling you about, and I run it in IntelliJ and showing you the plugin my company provides scanning your code. For instance, what we see over here is that we have, well, it recognizes the cross-site scripting issue, which you can see over here. The parameter, and basically the same thing as I showed you before. One of the fun things that it tells me is where it starts and where the actual flow is. However, you can also see what kind of possible things you have there to fix it. For instance, it says we can do something about, let me check here, use the string escape utils and escape HTML4, which would be a wise thing to do. However, this one was easy to find. The next one might be a bit harder. Well, although Sql Injection might be known to everybody else, we can take a look at this or the other one here, that we basically go into find user by name, and we see over here that indeed we have a Sql injection problem where we insert the parameter that we get right into the query. Of course, we can fix this with a parameterized query or a prepared statement. But a more interesting one is, for instance, this one. It is a path reversal issue. Now let me enlarge the code so you can actually see it. It tells me it starts at line 57 and it goes all the way up to line 69. And the thing is, I have a file over here and I try to save this file on my local machine or on the machine that this application runs. However, I'm using the original file name without doing any sanitization, for instance, and saying, hey, we use the upload path and just concatenate the original file name. But what if my file name looks something like this? Then we would have a path reversal issue. And that is exactly what this thing is telling me. What we can do, of course, is check with the canonical path if these things actually start with, the canonical path actually starts with the path I want it to be. So getting into your code and fixing it and getting pings right away when you create your code is essential for not bringing any vulnerabilities in while you are creating your application. So we spoke about your own code, your custom code, and that is the thing that comes to mind first. However, there is a thing underneath the surface, underneath the waterline, that is much bigger. If we just still looking at your application, we see that one of the things you probably use, and I know that a lot of you do, are dependencies, frameworks, libraries that do the heavy lifting for you. Basically, if you look at the binary that goes into production, 80 to 90% of the source code is things you inherit, things you pull in using your package manager like Maven or Gradle. So if this is your application, probably this is what you do, what you code yourself. And hey, using things like the Spring Boot initializer, it might have even be that some of that is generated as well. However, again, we take good care of our own code, but we should also take care of what you pull in. Think about it. Do you pull in things blindly? Do you know what you're pulling in and pulling in implicitly? Because frameworks pull in libraries, pull in libraries, pull in libraries, several layers deep. So when do you update your libraries? How did you pull them in? Did you look at who is maintaining it, etc., etc.? And we know that the open source usage has exploded over the last couple of years. But think about it. We take good care of our own code. But do we also take good care of what we pull in? And think about it. If we have to take something out because we see it's not working anymore, it's not maintained anymore, are we able to do that instantly? Because attackers are targeting open source. I mean, if a vulnerability is found in a package that is well known and used all over the place and maybe used by several larger frameworks, if a vulnerability is found in this, we have many, many, many victims. Vulnerabilities are identified all over the place in every ecosystem. But unfortunately, and these are still numbers from 2019, but Maven is the clear winner, as in more vulnerabilities known. However, if we look at these vulnerabilities more closely, we see that most of these vulnerabilities are not in the top level things that you put in your POM file or in your Gradle file. No, you pull something in like a Spring Boot starter or some other framework like Apache Struts, or name them. They depend on other libraries, and one of these libraries can be very, very vulnerable. And if one of these libraries that is several layers deep are vulnerable, then you might be in trouble as well. And we did have an example of that just recently, right? December 10th, I know it quite well. It was on a Friday. I was actually on vacation. But then something quite interesting came up. You probably all have heard of the Log4j or Log4Shell problem. And you've seen many of these things like you see the newspaper articles that you see here on screen. Interestingly enough, it's a very, very tiny library, and you probably have heard of it, and maybe even use it, that is used in many frameworks or many other libraries. If we check Maven Central, and well, I have the links later, but over 17,000 Java packages are, at least including at the point when the breach was made at December 10th, 17,000 Java packages included this Log4j version that was vulnerable. They did research on how many attacks were attempted in the first 72 hours of when this vulnerability was disclosed. That was over 800,000. But remember that when this thing was disclosed, that was on December 10th, the fix was already out. The fix for the initial problem was already available, I think, since December 4th or December 6th, so at least 4 to 5 days. But did you update? Nevertheless, we see that from the sources within Sneak, we see that 75% of all projects have Log4j not as a primary dependency, but as a transitive dependency, and people might not even know that they're using Log4j. That makes me think, like, how did you spin up your application? Is your application available? Say we found out that something is wrong. Are you able to pull it down, change the library, and bring it up again? Or does everything go horribly wrong? And how did you inform yourself when something like this happens? Let's get into the Log4j hack to show. So let me briefly get into this Log4j problem. It is a combination of logging a JNDI or JNDI request containing an LDAP URL. Point is, if I create a log statement with such a new URL, the JNDI request will get evolved. This was a feature implemented a long time ago. I think it was 2013 or something for some reason, but let's not get into that. If I own the LDAP server in this case, the lookup will be done at the LDAP server. And in this case, evil.com on port 4x9/evil. I own the LDAP server, and I give that LDAP, and as a response, I will give a reference back to an HTTP server. Again, I also own that HTTP server, and that HTTP server at that address returns a class. In this case, a compiled class, evil.class. If that evil.class has the right way of constructing and has the getObjectInstance method correctly, I can do whatever I want in that getObjectInstance method, because the class will be sent over and it will actually be executed. So this means we have, in a nutshell, we have a remote code execution. However, the first things were that it would only be working in older Java versions or older builds of Java, because this setting was set to true, like the trust URL codebase, in older versions and not so much in newer versions. However, this didn't seem to work quite well. It means that even in newer versions, you are vulnerable for this similar exploit. Let me show you. So I have an application over here, this same Spring Boot application, and let me run it. Let's see what the Java version is. Let's first go into the first exploit. So the Java version is 1.8 and build 111. So let's build this one. So I'm running now this application with an older Java version. And this was the initial problem. So let's go to the application, and first thing you see is that this application has a sign-in form. So if I sign in with something that is incorrect, like wrong and wrong, one of the things it does, it starts up my one password, but it also fills the filled login attempt will be logged with an error logger with Log4j. So let's go into the exploit. So I have a Log4j server prepared that creates an LDAP server and also spins up an HTTP server. What it does is the LDAP server gives the reference back, and it gives the reference back to this object. Basically, we compile this object to a class, and in this get object instance, we say open calculator. Basically, it opens the calculator on my main screen. Nothing fancy, but hey, can be interesting if you need to calculate things. So let's try this. Let's run this application. Let's run this server. Once both the LDAP and the HTTP server is running, let's connect to the server. So instead of doing the name wrong, I will go to this URL, the LDAP URL I showed you, /evil. Oh, /evil. And I will give it, of course, the wrong password. Doesn't matter. But if I sign in now, what we see is that immediately on the host machine, this thing is executed. And that is because it doesn't need the actual class to be in the class path already, because of that trust codebase value that was set by default to true in the older Java versions. Well, if you use a newer Java version, this setting is false. Okay, so then you're not vulnerable to this anymore. That is true, but it can happen that you're vulnerable to something different. Let me show you. So let me restart this application and start it with a new Java instance. Let's start it with a newer Java version. And now I'm using Java version build 292, which is one of the newer build versions. Cool. The application has started up, and one thing I can do again, let's try, my server is still running, and let's see what's happening if I do again this evil with a password that is not working. If I do this, I see that I will now have a reference to a class foo, which is the name I assigned to that class. But I only have the reference. I don't have the implementation, and as long as it's not on the class path, it doesn't do anything. But that's exactly the point, as long as it's not on the class path or in memory. This means that if you have this class on the class path, well, you probably won't have that evil class exactly on the class path. But if you have that class path, we can do something different. And that's what we do in the next hack. So if I look at this LDAP server, if I do a different thing, and instead of serving it the HTTP thing, I can also use a serialized body or a serialized payload. And I know that this application is using Commons Collection, in this case version 3.1, which has a serialization gadget chain in it. And I'm using that same gadget chain because I know it's on the class path to again give a deserialized version of that, of a couple of these classes, and again do an execution like here. So what I'm doing here, I'm using the transformers, and this is a well-known thing. I stole the code from a tool called Why So Serial. So look at that, and I adapted it a bit so it doesn't return the reference, but it now returns the serialized data. What it does is it spins up a new runtime, or it gets a runtime, and it evokes actually a command. And this command can be done as in this case, as a parameter. We create this payload and we serialize this payload and we give it back as a response. In this case, I will do the same, open calculator. So even though I'm on a newer version of this, I can, if I do a different URL and I give a serialized payload, we still might have the same problem. So let's check this out. If I do this over here, and of course I do a wrong password, let's see what's happening. And again, my calculator starts up. And now it's just a calculator, but I can also interfere with everything that's happening there, depending on what kind of user I have. But I can do arbitrary code executions. So even if you're on newer versions, even if I would run this with the newest Java 17 version, with this old Log4j library, we still have the same problem. If I would be developing, like here, I can scan right away. And I did already I will scan my application again to see if I have open source problems. And it scans my libraries based on my manifest file to see if there are libraries in my dependency tree and if there are any issues. Well, if I look at the POM file over here, I see I have 3 critical problems. The Log4j problem I just showed you, and that has a severity of CVSS score 10, which is basically the highest score. But also the comments collection library I use to do the deserialization. Don't get me wrong, you probably won't use this serialization or this library, but there might be a combination of libraries and a combination of classes that can create such a gadget chain in your application. I can go further into that, but that's a whole different topic. So knowing this, that you're having these libraries in, can already help you to see how you can fix this. For instance, to fix this issue, you can go to 2.15.0, but then again, that version might have and does have another vulnerability, but that's basically a different vulnerability. So we talked about code, we talked about open source, basically your application. But if you go deeper onto the servers, you will see that nowadays containers or similar are part of your cloud native application stack. That is the one thing that the marketing folks want me to tell, but now as well. So that means we have to take care of these things just as much as we take care of our code and our dependencies. Because I did a research on Docker vulnerabilities, on Docker image vulnerabilities, and it was already back in 2019. And what we saw is when we downloaded the 10 most commonly used Docker images, that all of them had vulnerabilities. Some of them more than others. But if you look at almost all of these vulnerabilities, they could be traced back to the operating system layer. For instance, the Node 1 was based on a full-blown Debian operating system, and that is something that you probably don't need. However, we should take care of it, because just simply creating a Docker file with the first line from Node and then taking the latest, or from Maven 3 and taking the latest version, might get you into trouble if you're not knowing what happens. So things like, we asked people in our state of open source security, like, when do you scan your Docker images for operating system vulnerabilities? And a lot of people are not aware of this. And I think you should. Also, how do you find out about new vulnerabilities in your deployed containers? Unfortunately, a lot of people don't. So let me show you what can go wrong. Okay, I'm running a Java application over here, as you can see. But this application runs in a container. And let me show you the Docker file. The Docker file looks something like this. It's a multi-stage Docker build, and I use Tomcat 8.5.21, which is an older version of Tomcat. However, I don't need to go into the application at all. No, I can attack the Tomcat container, because the Tomcat container contains an issue like this, which is an arbitrary code execution for different Tomcat versions. What it says that it was possible to upload a JSP file to the server via a specially crafted request. This JSP file could then be requested, and any code it contained would be executed by the server. That is interesting. Luckily, there is already something in the exploit DB. So let's take a look at that one. This is basically a Python script. But what a Python script does, it does 2 things. It has 2 payloads. One payload is basically testing, and it shows a payload with a JSP file it creates a payload and shows the payload with only A's to show if this thing is actually vulnerable. If it is vulnerable, I can load my second payload to actually do something. And this uploads a JSP file with a form and a text box with a submit button. And every time I put something in that text box and press submit, what the JSP code does is creating a runtime and actually executing it. Basically a web shell. Let's try this. I have the Python script running in a container, as you can see here. So let's try the first tag. Basically by typing check, it will try to insert poc.jsp, and it says it's vulnerable. So let me check. If we have poc.jsp and load it now, we see that all A's are available. Then the next one, I'm actually going for pwn, but .jsp, and you see it's not here yet. So if I do the actual exploit, and I showed you the code earlier, then that JSP will be uploaded, like now here. If I now again look at pwn, I am in the container and have a web shell. So I can actually ask, who am I? Well, I am root because by default a Docker container runs in root and I didn't set any specific users. But I can do all sorts of things like what is running here. Maybe I can do something with what kind of packages are running. Basically, I have a web shell at my disposal. And the point is, I didn't need to touch the application. I touched the base image that my Docker file was using to build up the container. I already scanned the application, and this is the result in using my Sneak CLI. One of the things that is important is that we can find the problems in the base images, but also in other libraries that are here. But the most important thing over here that I can find is that it tells me that I'm currently using an old version of Tomcat, like 8.5.21. I can update this easily to another version. In this case, it would be just the tag Tomcat 8, which will definitely now point to a newer version than the .21 version. Of course, it gives me all sorts of other options that might have less vulnerabilities, but hey, I am currently using a Java runtime environment and I want to keep it that way. If I would update to this version, if I would put this in my Docker file, I would not be harmed anymore by the exploit I just showed you. This also points out that rebuilding in some cases, if you use a tag like this, might be useful as well, because the base image can update. Anyway, we should take care of these base images. We should scan them just as much as you scan your open source libraries and your code. We spoke about code, open source, and containers, and that all these three have different attack factors. The last thing under the surface is your infrastructure as code. Think of your Kubernetes files and your Terraform files or things like that. Misconfiguration can expose parts of your application or your landscape, and you definitely don't want that. Combined with all of the other things, it can be even a bigger problem. So we need to take care of this. But what is the solution to take care of this? Well, basically it's three parts. First of all, we need to think about culture. Basically what I say with that is, don't stay in your own cubicle. Don't say, I'm a developer and I am only creating. No. If we think along the line of what needs to be done and that security is part of that culture, we need to embrace that. We need to make sure that we don't wait until the end and then let the security team do a pen test and find out if there's an issue. No, make obvious choices, make secure choices. Nowadays, you make choices that are scalable and maintainable, and security should be one of them. Mindset, that's the difference. Then we also need to think about process. Don't create a lot of new process and say like, hey, you need to satisfy all these tools in the build system. No. If I am a person that likes to develop in my IDE and have everything integrated in there, why not have tools available for me that I can use easily in the way I work now and not change the way I work? Some other people are more command line tools, and I showed you a different sets of tools that can be helpful. However, creating more process will never work. looking how you can integrate security and integrate that mindset in the current process will help acceptance of the fact that we need to take care of security as a developer or a development team. And then we have tooling. Pick the tooling that is in place and is correct and fits your process, not the other way around. Of course, the company I work for, Sneak, has a ton of tooling, and I already showed you a bunch of it, like Sneak Code, Sneak Open Source, Sneak Container, and the last one I didn't demo was Sneak Infrastructure as Code. But it's not so much about the tooling. It's that we need to get the tooling that fits your process and try to use the tooling in every step of our SDLC, our software development lifecycle. When you code on your local machine, like try to get rid of as much vulnerabilities as possible in your code, in your open source dependencies, but also when I create a Docker container. I can scan them already, everything I can scan already before I put it to my Git repository. When you're there, make sure that you scan it over there as well. And we probably already have something in a CI or a CI/CD pipeline, but you're not done then. At the point you go to production, make sure you keep monitoring that project. I mean, if you go to production, we know you know what kind of Docker image you're using, and you know what the dependency tree is. Why not scan that over and over again and get actively pinged so you know when something is wrong, and you can exactly at that point in time you can prioritize it in such a way that you may or may not intervene. And if you need to intervene, like for instance with the Log4j problem, you can do it right away and you're not too late. So we need to scan in all, and we need to scan in all aspects of that SDLC, and we need to do that constantly, because you hear a lot of the security folks say, yeah, you need to shift left, but there is no left in a continuous process. We need to do this in all sorts of ways to catch this early and often. Just like you have your unit tests to do it when every change you can run them and in multiple stages on your local machine, but also on your CI pipeline, we do have the same with security. Not only thinking about your code, but thinking of all ways of security that we need to embrace if you have the right tooling and the right process and the right mindset. Thank you for listening, and enjoy the rest of the show.